And again, we can continue this discussion after all the presentations and also in the chat. Right now, it's my honor to introduce Zuheir Altamimi from the International Association of Geodesy. His presentation title is Highlights of the IGS Contribution to the ITRF 2020. Thank you, Zuheir, for being here this morning, and I have just granted you the online floor.
Okay, thank you, Mira. And many thanks to the Central Bureau, to the IGS in general, for this great idea to have these many mini workshops. And I am so pleased to be among the first speakers in this kind of, presentation by the IGS. Okay, so my presentation will be about some highlights of the IGS contribution to the ITRF 2020. And this is the outline of my presentation. I will just recall the key points of the IGS contribution to the ITRF in general. Then I will show you the timeline for the ITRF 2020 in order for you to guess when the ITRF 2020 will be published. And we'll show you the expected sites and also the number of collocations, just a map of that, and how the IGS contribute to that aspect of the ITRF. And then we'll talk about ITRF 2020, which will be an augmented parametric reference frame, and I will tell you how. And I will show you some preliminary results. As the analysis of the ITRF 2020 has just started, and we had some delays in the contribution by the 4 techniques, there is not too much result that I will show, but I will share with you some preliminary result of interest to you, I hope. Now, the key point of the IGS contribution to the ITRF, just to recall that I remember I had such a presentation during the IGS workshop 2017 in Paris, and I also explained in detail these 5 key points. The first one is what I call the interlink, the inter-technique link that reinforce the ITRF datum definition, origin, scale, orientation, and thanks to IGS network, now we have almost all SLR and VLBI sites are co-located with an IGS station. And that's why we ask the IGS not to forget any single site to be reprocessed when a new reprocessing campaign take place. The IGS time series contribute to the determination of post-seismic deformation models, and for this I will show you some illustration. The third contribution is to the ITRF plate motion models because of the density of the IGS stations around the world covering most of the major plates, tectonic plates. The IGS contribution to polar motion is fundamental because it is, for me, from the result of ITRF solution so far, is the most precise polar motion results. And not the last but not the least, you need to know, and everyone knows now, that the IGS products provide a universal access to and densification of the ITRF. And just to mention that more than 80% of national reference frame are aligned to the ITRF, and that is thanks to the IGS products, which are fully compliant and aligned to the ITRF itself. Now, this is the initial schedule or timeline for the ITRF 2020. And just to remind you that the deadline, the initial deadline was February 10 of this year, noting that the dissemination of the call for participation was issued and published almost 2 years before that deadline. Despite that, we want the techniques to be on time. There were some delays. The technique submission are now complete. I wrote here when I prepared this presentation, except IVS and ILRS. In fact, the IVS submission was completed just yesterday. or the beginning of this week. And the ITRF still need to complete the time series to take all the historical data back to 1983. The solution we got from ILRS is just started on 1993 when the two LEGIO satellites were available. We extended the deadline until the end of May, actually Monday of this week. So the subsequent milestones of the ITRF 2020 will be delayed, and I will answer the question, and I feel there will be a question when the ITRF 2020 will be available. So wait until the end of this presentation to see the answer. Now, this is the map showing the expected ITRF 2020 sites. We will have more than 1,200 sites, as you see on this map. Just to recall, it is not only the IGS that contribute to the ITRF, it's also the three other techniques. And the ITRF would not exist without the contribution of SLR, VLBI, and DORIS. And by that, I want to take this opportunity to thank all the 4 IAG technique services for their contribution to the ITRF along the years. Now, this is the map that shows the expected IGS sites, and we will have more than 1,000, approximately 1,100 GNSS IGS sites. And by this, I want also to recall that we have about 93 collocation sites where IGS is contributing by connecting the 3 other techniques. VLBI and SLR taken alone would have only not more than 9 or 10 collocation sites. This would not be a viable reference frame to connect VLBI and SLR, and hopefully we have the IGS to do the job for connecting these 2 techniques, in addition to the fact that we have about 45 DORIS stations collocated with the IGS station. Here, note that we will have a very nice density in North America, thanks to NGS contribution. We will have a nice contribution in Europe, of course, but also in Australia, New Zealand. We cover all New Zealand. We don't see if it is New Zealand still, and also South America. That will help regional reference frame to be to facilitate their alignment to the ITRF using the new product that will be available after the release of the ITRF 2020, the new products of IGS, I mean. Now, this is the map where we have all the possible or expected collocation sites. There will be new collocation sites, like in South America, for instance, where we have San Juan, where in Argentina, where we have SLR and GPS. We have other sites where VLBI and GPS are collocated, like for instance in South Korea. These are new collocations. Now, the ITRF 2020, as I said in the beginning, will be an augmented reference frame. What does that mean? It means that in addition to the classical parameters, the position at a reference epoch T0 and velocities, we will continue to provide the post-seismic deformation parametric models, and Paul is working hard to finalize the parametric models for all stations that are subject to major earthquakes. So these models will be refined, and IGS is contributing in a fundamental way because we are using the IGS time series to fit these models, in fact. What will be completely new is that the fact we will provide the periodic signals, and these periodic signals will be expressed in the center of mass of a SLR frame. We will adjust not only for annual and semi-annual signals, we will also adjust for other satellite-based frames like draconetics for GPS, etc. We know that there are discrepancies in the annual signal between techniques at some collocation sites, and we will handle that in an appropriate manner, mathematically speaking. So just to show you some illustration about Repro3 data, here in this plot, I am showing 2 sites where we have 2 major earthquakes in Arequipa that happened in 2001, and Tsukuba, where the major earthquake occurred in 2010, if I am not wrong. Not what I am illustrating here, you have in blue the original raw data, the time series, in green the linear velocity, and in red, if you see that, is the post-seismic deformation models from the ITRF 2014. And you see how nicely these models fit the extended data of ITRF 2020 from Repro3 data. But again, although we have a nice fit to the new series, these models will be refined. As I said, Paul is working on that. Now, there is a big issue that I want to emphasize here in this presentation is the scale of the reference frame. During the past 15 years or more than that, I was always seeing in the ITRF past solutions, there was an offset between VLBI and SLR by about 1.4 ppb, which means about 8 millimeter. And at the beginning, nobody wanted to believe that, and I was blamed why I am not just fixing to zero the scale of VLBI and SLR by magic, because these two techniques gives the by nature the same scale, which was completely wrong, because we know that each technique has its own systematic errors, and we know that. Now, this is the first time of the ITRF history where we will have 4 independent and competitive scales stemming from the 4 techniques: DORIS, GNSS, SLR, and VLBI. Paul Obichung and Susan will come back to that, why we have now from the IGS an independent ITRF independent scale, which is based on Galileo data. That's what you should know, is that the fact that they, I mean the GSA, the authority of Galileo, they actually published the metadata and especially the ZPCOs for Galileo satellite. But keep in mind that this is based, or the scale, the IGS scale this time is based on 3.7 years of Galileo data. And if I am wrong, Paul, please correct me. Now, the second point that you need to know is that the ILRS, and I want to thank the ILRS, they took this effort to appropriately handle the range biases. And you will see the results of that effort from the ILRS in terms of the scale bias with respect to VLBI, for instance. Now, in the 3 following slides, I will show you the origin component and the scale time series of the 3 satellite techniques. Starting with the IGS, as you see here, the origin component, the time series in X, Y, and Z, you see a perfect alignment of the Repro3 to the ITRF 2014. And this is the nice work of Paul. So thank you, Paul, for that, for making sure that we have, for the IGS Repro3, a perfect alignment to the origin of ITRF 2014. Now the scale, Paul already mentioned that there is an offset. It's more than 1 ppb at epoch 2010, and there is a slight drift, and Paul already gave the answer that it is probably and more certainly due to the fact that we assumed constant ZPCOs. So now we know the reason. There is a drift, and this, I expect that drift to remain within the ITRF 2020 product at the end. Now, DORIS, here you see the 3 geocenter component, their time series, but also the scale. We have 2 things to see here. In the Y component, we have a kind of aperiodic variation, but also in the scale, especially this V shape here. And apparently the IDS Analysis Center investigated that after their official submission of their solution, and they might have the key to answer that question. And they asked me if they can reprocess the data, but I would need to wait until at least mid of July. So we will see, and I encourage them to reprocess their data, but their official solution is already a fair and good solution to be incorporated in the ITRF 2020. Now the ILRS origin and scale. In blue is the new results of the ILRS TX, TY, and TZ. And here in these plots, I did not remove the annual or semi-annual signals, just to let you see that. But from that, we see that there is a stability. This is with respect to ITRF 2014. We see that there is no offset or discernible offset or drift, which means that there is a kind of stability over the time, over the ITRF solutions, over the years of the SLR solution, which is a good sign of the stability of the ILRS or SLR origin that we inherit to define the ITRF origin over the past. And we will continue doing that for the ITRF 2020. Now for the scale in blue, you see the new results. And in red, I overlaid the past SLR solution used in the ITRF 2014. And you see a clear offset of 1 ppb between the two, bringing SLR scale closer and closer to VLBI scale. And this is coming to confirm what I was saying since more than 15 years. And I am happy to see that. And I want to acknowledge the work of the ILRS, but also the pioneer, sorry, I have difficulty to say that word, of some other colleagues, like, for instance, Richard Eanes. 20 years ago, he started to estimate the range biases, and others who took the continuity of that work, like Graham Appleby and his work in Hearst-Mansour. Now we are happy to see that that scale offset was real, and we will be pleased to see that gap between VLBI and SLR minimized to the level of precision of the scale determination. So this gives me now the floor to continue, I mean, just for to save time and to come to the conclusion. The ITRF 2020 will be an augmented parametric frame. I want to acknowledge the huge contribution of the IGS, which is fundamental. Of course, I was not able to cover all the 5 key points of IGS contribution because the analysis of ITRF 2020 input data is still ongoing. And at the end of the ITRF 2020, we will see more clearly the IGS contribution to this new frame. The nonlinear aperiodic variation in the IDS scale need to be investigated. To my last knowledge from the IDS colleagues, they are now about to know why we had that aperiodic variation in the IDS scale. Now, the IGS apparent scale, offset and drift with respect to ITRF 2014, we probably know the reason, especially for the drift itself, which is due to the assumption of constant ZPCOs. Now we are happy to see 1 ppb offset of SLR 2020 compared with the ITRF 2014 data, and that will actually minimize the scale difference between SLR and VLBI. And my estimation now, roughly speaking, that will be less than 0.5 ppb, less than 3 millimeter, compared to 1.4 ppb, which means 8 millimeter in ITRF 2014. So to answer the question, the ITRF 2020 scale, will we use the IGS contribution to the definition of the scale or IDS? The answer is too early to know. For the time being, we still need to clean the data to continue our work, and the analysis just started, so I cannot answer that question. When do we release the ITRF 2020? Probably fall 2021. And thank you for this great opportunity of organizing this mini workshop of the IGS. Thank you.
Thank you so much, Zuheir. Just a very quick question. Do you have any information about a plan to issue a new version of the WGS 84 that's linked to the ITRF 2020?
Oh, that is a good question. I had in mind to explore the IGS stations to isolate those who will be actually controlling the WGS84 frame. Up to now, I did not do that exercise, but I hope this will be done very shortly. And I hope there will be enough stations so that the WGS84 people will be able to align again the IGS, WGS84 to the ITRF 2020. Did I answer the question?
Yes, thank you very much. We have other two questions. Zuheir, you feel free to
Yes.
answer them through the Q&A, or we can leave them for the end. We have to move on to our next presenter.